is the yellow tips on each of these. These bars represent the medium through which this wave is traveling.
Oh my god, that's so cool.
You can build one of these. If I had one of these at home, I would play with it for hours. Okay, we'll see if we can get it, if we can generate a standing wave or a sine wave.
One's at the end of broken.
Yeah, well, this is old and battered.
I feel like Mr. Andres makes waves.
Yeah, we can see if Mr. Andres would build us a new one. What I want you to focus on is how does each yellow tip move?
Is it on like a string?
Yeah, it's on a cord.
It's on a piece of wire. But in what direction does each?
Up and down.
Just up and down. But which way is the wave traveling? Right and left. So the motion of each point in the medium bears what relationship to the motion of the wave? Yeah, it's perpendicular to the motion of the wave itself. So they're at 90-degree angles. Okay? That's important because when we get to, let me set this on the ground, when we get to our next kind of wave, which is our longitudinal wave, now each coil represents the point in the medium that's going to be disturbed. I can do this without breaking the slinky. How?
If you
Just let one coil go.
drop one coil at a time.
Yeah.
Ah, there we go. Actually, you know what? Let me do this. There we go. That'll go.
Yeah, there you
Okay. So at this point, each coil, right, is moving parallel to the motion of the wave. So it moves parallel to the disturbance. This is a longitudinal wave. This is the kind of wave that carries sound through air. So has anybody ever been near enough to something that was really, really loud so you could feel it? Okay. If you feel a sound wave hit you, what you are feeling is a compression wave. This is also sometimes called a compression wave. A compression wave in air. Okay. Shouldn't do that too often, because you will damage your hearing if it's not already damaged. Okay.